screen and please take it away.
Sure. So, hi team.
So Vishal, just before we start, this is being recorded, right?
Yeah, this will be live on YouTube actually.
Right. Okay. Yeah, cool. Just wanted to. Thanks.
So, hi team. Today, me and Pallav, I'll share my screen first, I think. Let me quickly. Can you see my screen?
Yes, we can.
Cool. So I think the topic for today's presentation is pod security policies, which falls under Kubernetes security. Me and Pallav are going to be presenting this. And this is going to be a primer on pod security policies, what they are, how to create them, any caveats that we have, and what does the future of PSP look like, and the alternatives. So this is the agenda. So the agenda is pretty simple and straightforward. What are PSPs? Why do we use them? How do we use them? What is the usage? It's going to be a demo presented by Pallav. There are certain caveats and what does the future of PSP hold? And then we'll open up for any questions. So pod security policies. So pod security policy is nothing, just it's a cluster level resource which we can create and which basically defines the security context of a pod. How does the security context of a pod looks like? If the pods satisfy the security context, they would be admitted into the ecosystem. Otherwise, they'll be rejected. And there can be many control aspects. We can take a look online as well. But the common ones are, do we allow privileged containers? Do we allow host networking? What kind of volumes the pods will have access to? So we can have control over these aspects of the pods, and we can specify them in the pod security policy. So this is just a simple YAML file of a pod security policy. It's in V1 beta 1. If that's we can have any name, and within the spec we can have keys, which is like privileged, false. We don't allow any privileged containers to run. We don't allow access to the host network, and only volumes, a config map, and say secret are being provided for the pods to run with. So this kind of defines a framework of the security context of the pod. So then we can talk over like, why do we want to have use of the PSPs? So as the name suggests, it helps us securing the Kubernetes cluster by making sure that the pods meet certain security requirements. If they won't meet the security requirements, they won't be admitted. They're very useful for multi-tenant systems like Platform 9. So wherein if the pods have access to the host networking, knowingly or unknowingly, they can make changes, and that can affect other workloads as well. So therefore, it becomes very useful for the multi-tenant systems. And we can say that although we have authentication and authorization systems in place, but they just only control what the resource, like if the resource can be executed or not, but they don't control, they don't have any control over the resource execution, wherein they don't control what kind of code is being done within the pods and everything. So that's why I think pod security policies kind of become important. That's why we want to use pod security policies. The usage can be explained within 3 parts. The first one is how we enable pod security policies. Then we can talk about creating policies in the system. And the third part is basically how can we access the pod security policies. And as I mentioned, they are done through RBAC systems. Yeah. So in order to enable the pod security policies or PSPs, they can be enabled through admissions controller. As we know, admissions controller is just a piece of code that runs before requests for an object or resource needs. So it runs between the API server, and it takes a look at, once the resource gets authenticated, it takes a look at if the resource needs to be added. And based on the plugins, it can allow the request to be modified, or it can reject the request completely. So the PSPs can be enabled through this plugin, enable admissions plugin, which has a value pod security policy. It can have more values. There are multiple plugins, but one of those values is pod security policies. There is a caveat here, wherein if you enable the pod security, if the PSPs, without creating the policies in the system, no pod would come up, because any pod that needs to come up would now start looking at what are the policies available in the system, because this plugin got enabled. And if there are no policies, so the pods won't come up. So the trick is to basically add the policies first in the system and then enable them through the admissions plugin. I have just pasted some two different kind of policies. Usually in an organization, we can classify the policies into leaning towards a bit more restrictive policies, and then the other ones that are leaning towards more permissive side of the policies. Restrictive policies, as the name suggests, which is on the right side of the screen, would be more permissive, so would be more restrictive, which they will prevent containers from using privileged access. Want to make sure that only specific volumes are accessed by the pods. And the permissive one, on the other hand, would be more permissive, wherein they will allow any volumes to be accessed. You can run as any user within the pod, even root users. You'll have host network access. We will have host bids. So, you lean towards either like two groups of policies within the organization. And the general consensus or the idea is basically the general authenticated users should be applied with more restrictive policies, and the admins are provided with more permissive policies because they have more control over the cluster. So using these YAMLs, we can create different policies in the system. And now, once we have created those policies, we want to make sure that the service account of the user needs to be binded with this policy. Once we have created those policies, we want to create roles which can use those policies. So as you can see on the left side, we have a cluster role, and the resource itself is pod security policies. Resource name kind of provides the name of the policy, and the verb here is going to be use, because we have a use verb. And then we can create a corresponding role binding, wherein we can bind this role to a service account, or can bind this role to all the authenticated users, or to the admin subject. So in this way, we'll be assigning access through RBAC. So I think this kind of provides a bit more theoretical understanding of what the policies are, how they can be created in the system, and how they can be attached to the different users or different class of users that we have within the Kubernetes cluster. Before we proceed, I would like, I think the next slide would be a demo or security policy in action, which Pallav and my colleague will take over and will show. We already have a cluster up and running where we want to show this. Over to you, Pallav.
Pallav, you're on mute, I guess.
Okay, sorry. Yeah. Hey, thanks, everyone. Is my screen visible to everyone?
Yep.
All right. So Abhimanyu gave an introduction to how pod security policy work and what the theoretical side of it is. Now what we'll be doing is taking a look at how these actually work and how we can actually bring them into effect onto our clusters. So I have a Git repo wherein all the files that I'll be using in the demo have been checked in. So I can provide the access to it later on. It's public. So I'll be demonstrating this with one of our Platform 9 managed clusters. So out here, we have a cluster AWS PSP K8S demo. But before that, the prerequisite to using PSPs is to enable that admissions plugin. So how you can do that over here is you can go to the workflow, create a new cluster. I'll just take a bare OS cluster, wherein I'll provide it a name, say demo, pick a K8S version. I'll just disable all of this, right? I will need one master and okay, and I'll take a couple of worker nodes. Done. Let's take a Flannel plugin. Okay. Now, what Abhimanyu showed in is one of his slides that we have to enable the pod security admissions plugin, and how we can do that over here is provide the flag and allow include the pod security policy plugin out here, and that's it. Once you click next, you can complete the flow, and within some time the cluster should be up and running. So that's how you can enable PSP. What's going to happen is that when a cluster comes up with this setting, it will not be able to deploy any pod. So the first step will be to actually go ahead and create a couple of policies out there. So we have this one ready, up and running. So I already have the kubeconfig downloaded. So you can download it from here. And I'll switch to my editor out here now. So this is the cluster that we are working with, right? If I just have the cluster info, it will talk about this is the one that we're using, AWS PSP K8S demo. All right, so the very first thing that we have to do is create a couple of policies, right? Because the very first step that you have to perform is actually go ahead and create a couple of policies. So out here, we have two policies. Squeeze this down a bit. Yeah. Right. So one of these is a restrictive policy wherein we have disabled privileged access, host PID access to host IPC access, and likewise. And then we have a permissive policy wherein this is more open, allows privileged access to most resources, right? So the structure is as you saw previously during in one of the PPTs, is that it's the API version comes under policy v1 beta 1, and you can define all of these attributes and assign values to them. This is exhaustively explained in the PSP documentation online. All right, so the first thing would be to, and I have put the steps here one by one. So the very first thing would be to apply these policies. So I do have the policies applied already. If I just run kubectl get PSP, it will list these two policies out to me, right? So one is called permissive and one is called restrictive. And in this demo, what we'll be trying to do out here is we'll pick this. We'll pick up two different kind of deployments out here. One is a very simple Nginx deployment and doesn't require any privileged access. And then the other deployment is called priv Nginx deployment that requests the host network access, right? So if you paid attention out here, the permissive one does allow host network, but the restrictive one doesn't allow any host network access, right? So what we are going to do here is try and deploy these. But first of all, let's go ahead and set up our namespaces and service accounts. So I'll demonstrate everything in a separate namespace. So I'll create the namespace first, MS demo namespace. So I'm creating a new namespace called NS demo, and I will be creating everything inside that specific namespace. Let me also create a service account within that namespace. I'll call it Nginx, and all my deployments are making use of that service account. Right. So let's call it service account. Cool. So if I run a kubectl get all in NS demo, right now there shouldn't be any resource right? Nothing is running as of now. So we are good at this point. Okay, so we have our PSPs in place. We have a couple of things ready for the deployments, the namespace and the service account. Now, the very first thing that is important to allow these or bind these uh, policies to your pods is to have roles defined. Now, in the PPT, you must have seen something similar that said cluster role out here. And out here, we have something called as role. So it's a very general RBAC concept in Kubernetes. A cluster role is applied cluster-wide, and a role is something that you can limit to a namespace. So out here, we are limiting everything to our custom namespace that we have defined, NSDemo. And we are defining two roles out here. One is a restrictive role and one is a permissive role. So the permissive role uh, allows the use verb on the permissive pod security policy uh, in the NSDemo namespace, and it can be accessed by all the extensions API groups. Similarly, the restrictive role does the same, but it defines the restrictive resource name, the restrictive PSP out here in the resource name. So two different roles for two different kinds of PSPs. So let's go ahead and apply them. Roles. Let's create the restrictive one first. And next one would be to create the permissive one. Okay, so if we run get roles in this demo, we should see both of our roles out here. So we now have both of our roles in place, right? So creating the roles was the next step. Now, the next, once we create the role, we need to bind this role with a service account, a user, or a group. And for that, we use something called as a role binding. So if we go ahead and take a look at the, let's first take a look at the restrictive role binding. So we have two different entities. One is role binding and one is a cluster role binding. Cluster role binding applies for the entire cluster, wherein role binding you can limit to a specific namespace, right? So what we are doing here is we're defining a role binding, we're naming it again PSP restrictive in the NSDemo namespace. And the role reference refers to the PSP restrictive role. So out here, this PSP restrictive rules role is referenced out here, and these are the subjects. So a mapping will be created between this service account, Nginx service account, and in the NSDemo namespace with PSP restrictive role. So any pod that uses this namespace will now have access to the PSP restrictive role, and via that it will have access to the restrictive PSP. So let's apply this role binding. So kubectl apply F bindings and so now that we have the role binding created, we will deploy this simple Nginx deployment. Now, one thing to understand here is that simple Nginx deployment doesn't require any special access, right? It can just run without requiring. The pod should come up once the deployment is created, right? And that's what the expectation is. So let's do that. Let's run this command. Right. And if I do a kubectl get all in this namespace, right? Everything is up and running. So this particular pod was allowed, and it was we were able to create this pod because it was able to resolve one of the pod security policies, and it could come up. If you want to see which policy this is actually picking, what you can do is do a kubectl describe pod and check the annotations. You come here and check the annotations. You can see the Kubernetes.io PSP is set to restrictive, right? So this pod has come up with the restrictive policy. It's using the restrictive policy, and that's why. And it did not require anything special, so it was okay with that policy, and it's up and running now. Next, let's go ahead and deploy the privileged one, the privileged deployment now that requires access to the host network out here. So it again uses the service account Nginx and uses the host network. So let's go ahead and deploy that. And now let's take a look at the current state of the deployment. Right. So this is the privileged deployment. None of the pods are ready. This is the corresponding replica set. As you can see, the desired state is 2, but currently nothing is ready. Now, if we copy this replica set name, the kubectl describe rs, and sorry. So if you come here and see the reason of the failure, it says that pod security policy unable to admit pod because the security context.host network, it's an invalid value. It's not allowed. So as expected, this did not run. The pod couldn't run because currently doesn't the Nginx service account that we created a role binding with only has access to the restrictive uh, role, which in turn gives access to the restrictive PSP only. And because of that, the pods could not be admitted by the controller. So the next step that we are going to do here is create a role binding, right? And we'll create a new role binding, and in that we will bind the Nginx service account with the PSP permissive role. Now this will provide access to the Nginx, provide access to the permissive policy to this service account, and we should be able to create the deployment should go ahead and should be able to create pods now. So let's do that. Let's go to the demo steps, copy this command, copy it. Right. So now that the role binding is created, what we can do is either we can wait for a bit for the deployment to create a new replica set, because usually takes a little bit of time for it to reconcile. Or what you can do is go ahead and delete the replica set itself and So now that I've deleted it, if I run kubectl get all again. So now this replica set has created its pods, and we can see that these pods are now up and running. And again, if we go ahead and check the annotations for this, for any pod from the privileged deployment, pod describe pod. This is we go and check, this is using the permissive PSP. So that's how that's all about how you can apply your PSPs to your workloads, and how you can manage them. Now, one thing to notice out here would be if we go ahead and let's delete this simple nginx deployment replica set, right? That will delete rs ns demo, right? Let it recreate the pods. Okay. So it has created a couple of new pods. If we go ahead and check the annotations again, right, you will see that it is now picking up the permissive policy. So the reason behind that is we created a couple of role bindings, both for both gave access to the both creator mapping with the permissive as well as the restrictive role. So the Nginx service account now has access to both the policies, and since if there are multiple policies that can be used to bring up a pod without hampering anything, without mutating anything, uh, the first policy alphabetically is picked up. So that's the reason why the policy the annotation has now changed to permissive. Had it been the case that the restrictive policy was named differently, it would have picked that one if it was higher in the alphabetical order. So that's the reason. So if you see something like this, don't be alarmed. That's just how the policy order works. That's all about the demo. I hope you were able to follow through, but in case you want to try it on your own again, you can take a look at this file. It lists down everything step by step so that you can follow along and try it at your own convenience. Yeah, back to you, everyone.
Thanks. So I'm gonna quickly finish it off with remaining few slides. Can you see my screen?
Yes.
Cool. Yep. So we're gonna quickly talk about the caveats now. So as I mentioned before, enabling PSP through admissions controller without creating the policies first would result in no pods coming up because there is nothing by the service accounts to look for the policy through which this pod can be admitted. And as Pallab mentioned, policies are looked up alphabetically. So it's better to name them in a specific format. It's just it helps you to know that bit. It helps you know implicitly via the naming which order was picked up. So you can start naming the most permissive one with like A alphabet dash permissive policy, and the restrictive one could be named with Z dash restrictive, so that you implicitly by looking at the annotations, you know in what order the all policy were picked up in case multiple policies are assigned to a service account. So this can help you a bit. So we can quickly now talk about the future of PSP. So we mentioned that pod security policies, what they are, but as of 1.21, they are being marked for deprecation. And they will be used for a couple of years before they are removed from the ecosystem. The reason being, there are many reasons for that, which we'll discuss, but right now the enhancement work is in progress for prototyping a new feature, which will be released from 1.22, which will be on the same lines as PSP, but will be a little bit more simplified. So the reason why PSPs, or at least the current format of PSPs, which might include a bit more rehaul in the future, is going away because pod security policy, the way they are written, it can allow customers to accidentally give broader permissions than necessary, because a service account can have multiple attached policies and the order matters, the alphabetical order. So now the second is there is no inability to run dry run, to perform a dry run on an existing cluster. So you want to introduce pod security policies for an existing cluster. There is no possibility of running, like doing a dry run, and that can cause some temporary failure or glitches. And also there are widely accepted alternatives like K-Rail. We haven't personally used them, but it's a very strong community of third-party security policies, which you can take a look at and involve in the system. Even though they're going away, but the new draft is on the same lines. They're just going to simplify the PSPs. So it gives you a bit more understanding what the security policies are, and it's always a good point to start looking at the security context of Kubernetes. That's this. And before we open up for questions, just Platform 9, it's a let's say startup in Bay Area, and we work on, as we mentioned here, we work on managed Kubernetes and open source, OpenStack, and technologies include Docker, Kubernetes. And yeah, we have a lot of hackathons and tech talks like these. And yeah, you can easily take a look at our offerings and try PSP as Pandar mentioned, and you can onboard yourself through platform9.com website. And we are always hiring. I think that's it from our side, from the talk perspective. Any questions right now, or maybe we can take it later? I don't know the format too much. So,
Abhimanyu, I had one question.
yeah,
so you mentioned the PSP is being deprecated in 1.21.
Yes.
And the alternatives being things like either Kyverno or OPA or something similar, right?
Mm-hmm.
So are you gonna wait on either 1.22 spec to come out, or gonna switch to one of these like OPAs, or Kyvernos of the world?
We are right now moving ahead with PSPs for customers, and we're gonna take a look at. So at least in the deprecation notice, it mentioned that they're gonna deeply simplify the policy. So if you have very nascent use of the PSPs, you waiting for 1.22 would be beneficial, because it's gonna use simple rules. But if you have been using in a very complex way, it's good to look for alternatives. They allow you to handle it in a more deeper way and more complex rules. But for simple rules and simply having a more restrictive and more permissive policies, I think waiting for that.
Makes sense. Makes sense. Thanks.
Yeah.
Anybody else has a question, please go ahead. We have 4 or 5 minutes for sure.
Hey, Avenue, this is Anurag. Yeah, that was a really nice session. I have one question. Let's suppose we have a cluster, right? And we enabled PSP on it. And as far as I understand that every service account, or let's say as user identity, needs to be attached to at least one PSP, right? So what will happen to our Helm deployments which were previously running on it, which were using service accounts? Do we have to manually add at least one PSP, or means what will happen?
So if a new, yeah, go ahead.
Yeah. So Anurag, the thing here is that if you have enabled PSPs after you have already deployed a few pods and your Helm deployments, those will not get affected. Anything after that will not come up. Any pod after that, after you've enabled PSP and there's no policy or anything like that, they will not come up. So if you are creating something new afterwards, make sure that you create the appropriate roles and rule bindings. Also, if any of the previous pods restart or they get recreated, they will also not be admitted. So yes, it's best to have those bindings created as soon as you can. So that's how it works. But in practice, if you have something running and you enable it later on and then you create policies, so the previous workloads will not get affected as long as they do not get restarted.
Okay. Thanks.
It just restarted, right? I mean, in case if the pods which I've already created and if the reschedules, let's say if underlying node is I just drained the underlying nodes.
Right. Yeah, they should get affected as well. Yep. Because they will have to go through the admission controller now, and it will realize that okay, PSP is enabled, so I can't let you in. So please come with me with the appropriate permission or the proper rule binding.
Got you. And while you were demoing this PSPs, I've seen run as user or FS group, which are usually a part of security context.
Correct.
Does it mean the PSP can also restrict root containers? Like if I wish to run rootless containers always, or if I wish to allow only rootless containers or pods?
It absolutely can. It gives you, I think, 3 level of access. So there is run as any, must run as, and must run as non-root. And if you set as must run as, then you can actually define the range of user IDs, and then you have the must run as non-root. So that will enforce that you set it as must run as. I mean, it should run as a non-root user. And the run as any is more open. You can run as any user anyway. So there are different granularities. If you go check the documentation for each and every attribute that you or the field that you enable, there are more customizations that you can do out there at the FS group level, at the user level, run as user level, the volumes that you allow, the networks that you give access to, Linux capabilities, etc. So all those can be manipulated via the TSPs.
Got you.
So one question. This pod security is differ from the in the CNI we have, right? The CNI security means that it's a Calico and all. So this is related to that, or this differs from the CNI security, because that will also be implemented via plugin, right? Yeah. Over to you.
Can you elaborate a bit on that? Sorry. So, I mean, I think they are a different concept than CNI security. I mean, this just simply controls that whatever the pods that are coming in should respect this security context. And if they don't, they won't be scheduled. So even if Calico pods needs privileged access and you haven't allowed those permissive policies, they won't come out.
Okay. Sure. Thanks.
Any more questions? If there are
Devdutt, this side. So if we need a more granular policy on the pods, then we should go to OPA, right? Instead of going to using the PSP, right?
I mean, yes, I haven't personally evaluated OPA, but if they provide you with more granular permissions, or because PSP right now in its entirety have a lot of granular permissions, it's just the complexity of it. They want to reduce it. But if OPA provides you with more granular restrictions and you need those, you can take a look at the third-party toolings that we have. Does that answer your question?
Yes. Thank you.
I can stop sharing now. If there aren't any more questions, I'll stop sharing.
Cool. Thanks a lot, Abhimanyu and Pallab. That was a great session. Jaideep, you want to go next?
Yeah, thanks, Vishal. Let me share my screen. All right. Am I audible enough?
Yeah. Yeah, you're audible.
And is my screen visible? All right.
Yes, it is now.
Cool. All right. The slide is on, right?
Yep.
Okay.
Yep, we can see the deck.
All right. All right. Okay. So hello everyone. Really appreciate for your folks to actually listen on for the talk that I will be presenting. So this talk is about my experience and learnings for implementing GitOps and how we moved from a traditional continuous delivery pipeline and moved towards a GitOps. Well, GitOps is a buzzword, and I'll try to explain if it makes sense to you to apply for your use case. All right. Right. So this is the overview of the talk. We have first we will discuss like what is GitOps. Then we will try to compare with traditional CD pipeline with what all challenges it has. Then we discuss about the tool that implements GitOps, that is Flux Cd V2, and its components in the toolkit. Then we talk about like why GitOps, the benefits of it, and then and also why Flux, right? You know, there are other tools in the market right now. Why do we choose using Flux? Then there will be a demo. And lastly, I would like to actually conclude with what all the challenges with GitOps that I faced it, and more than happy to take it from other folks who has their experience. Right. So yeah, let's get started. Right. So what is GitOps? Well, GitOps is a term that is coined by a company called Weaveworks, and they are the creator of the of Flux CD tool system as well. In GitOps, we treat the source of truth as the Git repository. And now we have moved towards an infrastructure as a code systems. Everything is actually version controlled and pushed to Git repositories. Now GitOps actually takes it to the next level, that whatever even you are versioning it, you can actually apply it into your Kubernetes cluster. So the state maintenance is actually in the Git, and it reflects whatever that you have on your Kubernetes cluster as well. Declarative provision of manifest, of course, all the of the YAMLs or the Helm charts or whatever that we use are actually declarative in nature. So GitOps suggests that there are software agents who are responsible for the reconciliation of the state. And they are responsible to ensure that whatever that we have on the Git repository, it is actually in sync what you see in the Kubernetes cluster as well. There are alerts and notification on state divergence. So GitOps suggests that all the if there is any kind of a state divergence that happens, send proper notification and alerts to appropriate stakeholders. Changes are observable in Git history because it is using Git. So everything that you do, write your manifest and everything is actually part of your Git history. So you can definitely go back in time and see what was changed and where. Operation is done using pull request and merge request. So it doesn't pull request and merge request is a very common practice these days, and all the operations are done by that. So it becomes very easy for the teams who are not really familiar with a lot of cloud native tooling, right? For example, developers who can actually operate. If everything is set up, they can just operate on top of this. If you think about GitOps, like it just breaks your CI/CD system, where you take the CD inside your Kubernetes cluster. Your CI system still remains the same, but you take the CD inside your Kubernetes cluster. Right? So this is a very high-level view of what GitOps is and what does it actually suggest. Next, we'll compare with traditional CD pipeline and what are the challenges with the traditional CD pipeline, what GitOps solves for us. For example, this is the first challenge. If you look at it right now, this is your standard Jenkins pipeline. You have a CI plus CD system. So there is a developers who are pushing to code repository. Then there is a CI system which actually reads from the code repository, and then once your standard build procedure has been done, pushes to the container registry, the CI system now requires an API credentials and access to the Kubernetes cluster. So it is more of a push-based pipeline, right? Because you're pushing it from the outside. But the challenge here is you have to maintain your secret management, share the credentials outside the environment. When you share it outside the environment, it can become a bit tricky. For example, if you are working in a fintech domain, and that was a use case for us while we were actually doing it for one of the clients, right? Because you are in a fintech domain, the compliance and these things actually starts kicking in more often. So that's the first challenge. How GitOps solves it? Because GitOps is a pull-based pipeline, what it does is there are the controllers who are actually pulling continuously from your repository. So if you look at it, that this is your deployment repository, right? So deployment repository is where all your all your manifests are actually pushed, right? So the controllers pull it from these repository and then apply it to the Kubernetes cluster. Challenge number 2, like monitoring systems after deployment. Well, in your traditional CD pipeline, you can definitely write your code, which can do retries and actually check if your deployment has been successful or not. But that's not a very first-class way of doing these things. You will have to write enough code, and there will be a lot of try and errors before you conclude, like, okay, this thing actually gives us enough visibility what happened to our deployments. You'll have to implement the retries and failures at your own end. Then and then of course integrate with the alerts as well. So this is doable, not denying it, but again, there's a lot of effort that needs to be put in. What's the solution to it? So GitOps suggests monitoring. Most of these tools actually come with their own monitoring solution and support retries, right? So in case of a failure, it can actually take care of retrying it again. Challenge number 3, cross-environment access. And this is like very familiar at wherever I have worked in the past at infrastructure level. Cross-environment access becomes a pain and a problem. You have to connect your multiple environments with your single, let's say, if you're a team who is using a central Jenkins server, and they have to connect to the multiple environments every time, because the different environments are running on different regions or different cloud. So you either end up doing a lot of VPC peerings, or you do have to do a VPN connections between these environments. And this increases the overall overhead of networking for networking on the infrastructure team as well. Like they just keep on, just doing peering again and again. Solution: since GitOps is a pull-based pipeline, there is no more need for cross-environment access, because everything is actually residing on the Kubernetes cluster itself. So it can just pull it from the using the Git token and get whatever the state that is actually pushed to the repository. Challenge 4 is environment-specific configuration. Now, what happens is that while you are doing, everything is good, you have your version control, manifests are there. Always a challenge which I have run into, and I'm pretty sure most of you will also agree to, how do you manage the runtime configuration? Configuration is a challenge. Now, well, one or the other way is, if you are handling secrets, well, you can keep on pushing to a vault. You can write to a vault and your application can read to it. But again, that requires a developer effort. Or you can write it to a console KV. In past, I have used console as key value stores, which will have my key and value names, and that is consumed by my application. But again, that's actually stored somewhere outside. So every time I have to go and change it, somebody has to go into a different environment and then change those key value pairs. With GitOps, what you really can do this, you treat configuration as a code, and everything becomes part of your Git repository, even your secrets, right? Now, when you say, okay, secrets, hang on, why we are pushing secrets to Git repository? Well, so GitOps, in particular, some of the tools like Flux supports SecureOps, which I will be discussing going forward, which actually encrypts your secrets in your Git repositories as well. So everything resides in the Git repository, be your manifest and as well as your runtime configuration. And then you can definitely separate it out on your environment specific, be it on dev, QA, or if you want to move towards a production, which is a very unlikely solution for at least 6 months, you can do that. Right. Besides that, there are other benefits of GitOps. It is a repeatable process. Now, since it is actually part of your source code repository, the teams and new joinees can actually leverage on the process and see that, okay, everything is actually part of the Git repository. I can start consuming it. It becomes very seamless and easy. The chances of human error reduces drastically, because now all the runtime configuration are part of your Git repository. So everything you can actually start consuming from there. And of course, third is operate on existing Git knowledge. Git is, be it developer, DevOps, practitioners, whosoever, or SREs, they are using Git underneath. And operating on Git makes life very much easier and simpler, right? So I'll discuss like why we choose towards moving towards GitOps. So we were actually a small team of DevOps practitioners, and developers were actually pushing multiple builds in a day. And they used to get blocked on us every time, like, okay, look, can you go ahead and deploy? Well, of course, at the end of the day, we didn't have to do a lot. There was an Helm upgrade or do a kubectl apply, but developers were not really, didn't have that skill set and in their armor at that point of time. So GitOps made more sense. Okay, just operate on Git and you will be able to push all these things to your Kubernetes cluster, at least on the test and QA environments. Right? So developers were always blocked on DevOps team and wanted to deploy new images. PR-based model was more suitable for devs, right? Because they said, yeah, if it is all PR-based and I have to go ahead and just change my Docker tag, well, I can definitely do that. My CI pipeline runs, I get my Docker tag on my email or my Slack. I can just use that Docker tag, push it into the my deployment repository, and GitOps will take care of that. So they were pretty happy with it. Now, security team had concerns of accessing K8 clusters from outside, right? And they said that, look, I mean, they had an apprehension that we are going towards the SOC 2 type 2 kind of a compliance. And now if you're doing up these kind of accesses, how it will work? So GitOps made more sense towards them that, yeah, look, they're fine. We don't want anybody to actually outside from outside the environment, right? So these were major reasons for us to actually go ahead and choose towards GitOps. Now I'll talk about Flux Cd. So Flux Cd is actually a tool by Reworks, as I've discussed previously. They were earlier, I think it has been using Flux Cd version 1, which has been almost for 4.5 years, and they recently came up with Flux Cd V2. Now, Flux Cd V2 is different from V1. It is actually broken down into more microservices, if I have to put it in very layman terms, and had different components and software controllers, each having a different set of responsibilities. And the idea behind Flux Cd is that they want to push towards, people are able to extend their own continuous deployment pipeline by themselves by providing an SDK, which can be used as plugins. So you can create your own plugins using Flux Cd V2, right? So what does GitOps Toolkit is? So GitOps Toolkit is a set of composable APIs for continuous deployment. You can actually, they provide like opt-in controllers that you can use in if you have to create your own CD using GitOps. And it is built with Kubernetes controller runtime libraries. And it works with Kubernetes events and CRDs. And all these software agents are actually responsible for reconciliation of the designated API objects, right? So whatever the, let's say there are different CRDs that are created by different controllers. So they ensure that they are actually syncing in by reconciling it at a given interval of time. And of course, it has an ability, an SDK to extend and build your own CD system by itself. Right. So if I take a pause and say that if GitOps is actually the interface, Flux Cd is one of the tools that implements it, right? To put it in a much simpler manner. So what are the GitOps toolkit components? So there is a source controller, there is a customized controller, there is Helm controller, notification controller, and image automation controller. We will talk about this in a very brief manner, like what exactly each component do. So first is source controller. So source controller is actually responsible for your source registration, authentication, and resource fetching. So it basically, let's say if you're using a GitHub repository, it will, push a private, create a private key, push it to GitHub repository as a deployable key, and use it for syncing the state. It also fetches the resources and creates those resources which are consumed by other controllers, right? Like for example, customized controller and Helm controller, which use the source CRD created by source controller. As of now, there are three kinds of repositories supported by source controller. It supports Git repository, Helm repository, and S3 buckets. Then second is customized controller. So customized controller, Flux is heavily dependent on customized for creating those overlays, and customized controller is responsible for generating manifest with customized. It does a garbage collection. So in case if you remove one kind of a let's say a help chart from your Git repository, it will ensure that it gets reconciled and removes it, and all the reconciliation for the state is taken care by the customized controller. One can deploy specific pipelines in an order. For example, I would want to spin up my backend first and then actually run my front end first. So this is all can be defined using customized controller. Customized controller also notifies the notification controller if any kind of a state change that happens. Third is a Helm controller. So Helm controller. Now, one primary reason which I will be discussing is like the Helm controller. Flux has a first-class support for Helm control for Helm charts. So if you have like existing Helm charts, you can utilize it and extend it on top of your existing Helm charts using Helm controllers. Because what it does is it actually watches Helm chart object for any kind of a revision change. It supports automated remediations, any kind of an installation or upgrades, and can be handled using the retry mechanism provided by the Helm controller. You can, of course, define sequence for Helm install and upgrades using Helm controller as well. It can also report any kind of a release status to notification controller, any kind of a version upgrade, installation or successful failure. Everything is actually taken care by the Helm controller as well. Fourth is notification controller. So notification controller actually is just not for notification, by the way. What it primarily do is it actually deals with incoming and outgoing events on the Kubernetes cluster. So what we discussed previously, that you can GitOps supports a pull-based pipeline, but with notification controller, which has been recently released with Flux V2, you can create a push-based pipeline as well, an event-driven pipeline. So how does it do that? Notification controller has a CRD which can expose it via a load balancer, and you can configure Git hooks or via Jenkins to send in any kind of an event that is done can be taken by the notification controller. Notification controller actually tells the reconciliation about any change in event to different controllers. Any reconciliation events are actually taken care by the notification controller, and it also captures events from reconcilers. And of course, it can send alerts to different Slack channels like Slack, Discord, or Microsoft Teams. One more thing that I would like to highlight, which I did not write in my slide. In case if you want, if you have a an L1, L2, and L3 kind of a support, and you want to, and who is basically your on-call support, and in case anything goes fail, or you want to integrate it with PagerDuty, so what you can do is, GitOps supports, and Flux primarily supports Prometheus endpoints. So you can configure Prometheus server, scrape those matrices, and you consume it on top of a Grafana and configure PagerDuty. So you can integrate it with PagerDuty or an SNS or an SES notification webhooks as well. Image automation controller, well, that's pretty standard. It actually scans the image repositories. It updates YAML files with new Docker tags, and also pushes changes to the Git repository as such. So I'll say that why we opted for Flux was a couple of reasons. First was to reuse the existing Helm charts. So we had our existing Helm chart which were working fine. But as I said, that the DevOps practitioners team become a blocker for others. So we wanted to leverage on our existing Helm charts and consume it. And Flux has a first-class support to us, right? It was an extended solution and a loose coupling. Now, when I say extended solution, loose coupling, what I mean is that I wanted to implement GitOps on my dev and QA environment. But for that, I want to use traditional, go on the system and apply my Helm charts step by step. So there was nothing that was changed underneath for us and for the DevOps team. It supports SOPs. So supports, when I say SOPs, so SOPs is, I'll give a quick brief about what is SOPs. SOPs is SecureOps by Mozilla Foundation, which enables you to encrypt and decrypt your JSON and YAML files, right? So what we are doing is we are actually encrypting our secrets using SOPs. Now, SOPs supports multiple ways of encryption mechanism. It supports asymmetric key pair, which is the native way, which we have been using. It also supports Azure's Key Vault and GCP's and AWS KMS as well. So you can integrate it well with it. So SOPs is actually another project in itself, but Flux supports first-hand support for SOPs. And the fourth is the lightweight and less maintenance. When I say lightweight and less maintenance, why? Because it doesn't have any UI, and I have a joke that if you have a UI and you have like more buttons to press, you get more confusion. No UI, no buttons, less confusion. So I think these were the primary reason to actually move towards a Flux-based deployment. I would like now to actually, how was the repository structure that was created for us? So if you look at it, there is a K8S GitOps, there is K8S Helm charts, and K8S Helm values. We'll definitely look into a demo when I showcase the demo. But if you look at it, these are the Helm chart, which was the previous state for us, right? There is a Helm chart. We have a Helm chart for service 1, and these are the chart templates values, service 2 chart templates values, right? And we have Helm values. So Helm values are configured separately for every environment. Like for service 1, this is my my Helm value. For my production, this is my config values, and these are my Helm values for my QA environment. Right? So Helm charts and Helm values was the existing one. Now what we built was we actually configured GitOps in the same repository, but for different environment as well. So if you look at it, K8S GitOps dev, this is where our GitOps configuration was residing in line. Right? Customization and customize config.yaml, I'll come to it in the demo, but customization.yaml is basically just having up, defining the resources for the layout. Now service 1 and service 2. So the service 1 is basically like all the config maps and secrets were actually part of this directory structure. Customization.yaml was again defining the customized layout. Release was the Helm release, which was is a CRD controlled by the Helm Controller, right? So this is our directory structure, and similarly you can separate and create one for QA and production environment. But the good part is like everything resides in this single Git repository. Nothing goes outside, even the secrets. So we were even encrypting our config maps as well, because we didn't want to even expose our URL endpoints, which were part of config maps, right? So we were encrypting everything and storing everything in a single Git repository. Finally, if you look at it, this is how the GitOps workflow looks like. So there are these developers who are pushing code to the application repository, and then their standard Jenkins pipeline starts. It runs a test, do the build, and pushes to the Docker registry, right? Meanwhile, if you look at this is a team of DevOps at number 6 here, which will be pushing the changes for Docker tag as well as the config maps. Okay. Now, these config maps which are pushed to the deployment repository, and all of them are operated on the pull request. So a DevOps team guy or someone from the development team, folks can actually, merge the pull request. It all looks good. Now, what happens is on the Kubernetes cluster side, it pulls the changes, like the source controller pulls the changes and applies those changes. Here, all the controllers starts coming into the picture. And K8S cluster, of course, pulls from the Docker registry as well, and then pushes the alerts on Slack about success as well. Features now, or should we take out the demo? Vishal, am I audible?
Yeah, you are now. There was a little bit of, I would say, 10-second breakage in between.
Lag. Oh, okay. So, yeah, how much time do we have?
We have time.
Decent. So, okay, all right. So let me actually do the demo first. Let me share the screen, because right now I've just shared my. I'll have to share my everything. New share, complete desktop. Is my complete screen visible?
Yeah, we can see the browser with your demo.
Hello. Perfect. Okay. So I'll start with this. I'll be switching in tabs in between. Bear me if it gets too fast. More than happy to come back it after later. So we have this initial repository. Now, what I will do is actually bootstrap it. I've prepared most of the things here. This is the demo. Now, I've already exported my GitHub token. Right. This is exported, and what I will do is actually bootstrap my GitHub repository. What I'm saying is that bootstrap my GitHub repository. These are the components that I want to install. This is the path where I would want to install for my dev environment. Considering that if it is bootstrapping for a dev environment, I suggest that this is the path where it should be installed. This is my branch. I'm the owner, and this is my repository. So let's try doing it. Right, all the components are healthy. If I would switch to my K8S for now. So here we look at our Flux system. We have our Helm controller, image automation, all the controllers have been configured here, right? Now I'll go back again to my shell. Now what I will do is I'll do a git pull origin main. What just happened that when we did a bootstrapping, the Flux controller actually pushed this configuration to this particular path, right? So yeah, now we have K8S. Before going ahead, I would like to apply my notification controller so that every changes that we do, we get an alert on a Slack. Okay. So, right. So this is our Slack channel, which will have our Flux Cd demo alerts. And for the pod deployment, we will be doing up a pod queue instead installation. Can someone mute, please? Yeah, right. So let's begin. First of all, what I would really like to do is just getting a bit of lag. I've created my directory structure already, so I will copy it. Is the font visible, guys?
Yeah, it is good.
Yeah, cool. Okay. Right. So what I did was I actually just copied my Helm chart and Helm values. So let me actually show my tree first. L1. Actually, let me do it. 3. So what do we have? So this is our GitOps configuration. This is a dev environment, and this is the Flux system. This is the Helm chart. We are using BotQ. And this is the Helm value for BotQ, dev-config.yaml. So the values that will be passed to the Helm chart. Now, what I would like to do next is primarily configure my BotQ for GitOps. So what I will do, I'll go here. Before that, let me actually copy my BotQ GitOps configuration, which I've already created. And K8S GitOps dev. Okay, so if we go here, K8S GitOps dev, this is our BotQ. Now, if I go inside this BotQ here, what do we have? We have customization.yaml and release.yaml. So let's just look at release.yaml first. Now, release.yaml is basically it's a Helm release CRD, which I say that, okay, this is what we want to run. This is the namespace. This is the chart. So this is the chart that is referring to the Git repository, name Flux system, namespace Flux system, and this is the path to the chart. And sync it up at every 1 minute of interval. And the values have to be read from the config map. So this value key, where does this come from? Dev BotQ service.yaml. So let's actually look at this customization.yaml. Now the customization. Let me clear my screen, which will be more easier to read. Yeah. So if we look at it, so we have the resources secrets and as release as well. Secrets we will create just now using the SOPs part. Now we have the config map generator, which now this dev BotQ service.yaml refers to the the values file stored in this path, right? So it is referring to the path which is part of the Git repository in itself. Right? The configuration customized config will come back to it. So now let us actually create our secrets. So I'll be copy pasting some commands. Just spare me for a minute. So I would, before doing that, let me just show the. So this is, I don't know how should I look at it? Yeah. So this is my YAML file, and it has like this token for sending alerts to my Slack channel. Right now, I would like to actually first of all generate a Kubernetes secret out of it. So I'm switching the screen just to get my command. So what I will do first is so let us look at this BotQ secrets.yaml. So this is my com_config.yaml file. Well, this is good, but I cannot really push this to my GitOps GitHub repository. So what we'll have to do, we will have to create a encrypted using SecureOps. So, sorry. Yeah. Now what I will do here is I'll create a configuration here. right? So what I did was I actually just configured to use SecureOps. This key underscore FP is my private key, which is part of my local system. So this private key can be shared across the DevOps engineer who are actually applying these changes. Now, let me go to the system, GitOps. If I have my .sops.yaml file, let me do an encrypt in place botcube secrets.yaml. It is now encrypting it. So if I look at it, botcube secrets.yaml, yeah, now this whole data is actually encrypted. If I have to look at it, I'll have to have my private key and yeah. So then only I will be able to see the actual secret. Okay. So now we have configured SOPs here. What I would like to do in now is export this key and make aware about my controllers that look, this is the secret key that you will have to use when you have to decrypt, okay, at your end during the runtime. So I'll run this. So yeah. Waiting for customization. Error. GPG import. So we get, if you look at it, we actually start getting an error. Wallet open. Oh. Okay. Nothing exported. Just give me a minute, guys. Faces some lag. Okay. Let me just do it really. The commands didn't work as I was expecting them. But again, sorry. Right. So I'll have to export this. C_SP. Yeah, this is done. Let me just run the command again. SOPs already exist. I'll have to delete the first. Let me just delete my secret. Yeah, this is now created. Now we'll try to reconcile again. Yep. Okay, waiting for reconciliation. Okay, there's some error that we are actually getting. I have a backup video as well, which I recorded. Can I show that? Is it okay?
Yeah, go ahead.
Yeah. Sorry about that. I don't know why it worked. It worked till last night, but I don't know why it didn't work. So I'll actually take the moment and actually go where we wanted to show this. I hope this is visible. Is it visible? And not really the best, but at least something is working. So what I really wanted to do here was create the secret. We created the botcube secret here. And then we again encrypt it here, which is already done. The secret has been encrypted. Now, yeah. So this is what I was trying to do. I don't know why it didn't work for this reason. Now this here, what we look at it, the secret has been created for Flux to reconcile. So I will now copy the customization.yaml at the root directory of the path. Okay. So if you look at it, there is this, we are saying that these are the two resources, BotQ and Flux system. And customized config is used so that in case any Helm values that is changed, Flux can come to know about it and then apply those changes. Right now we are moving towards now everything is prepared. Now we are moving towards a pull request based approach. Okay, so this is all what we will be committing. So we push let's think about it, how a developer will be pushing the changes, or a DevOps, enabling GitOps for BotQ and using Helm charts and Helm values. So now we come and open up a pull request. So this is the what we were talking about. We start observing our system. Okay, so here the controllers are running. You'll see that okay, we had enabled our Slack alerts, so all the notification controllers start sending these alerts. Our source code has been integrated. Now in a while we will start seeing these changes. Now, if you look at it, it did a reconciliation, but it said, oh, namespace BotQ is not found. Right? So what we do, we just create again the namespace. It is created. Now let's just wait for a minute, and it will, because it has its own retry mechanism, it will reconcile again. I'll take it a bit fast forward. So it did the reconciliation again. Right. Yeah. So now it detected that the Helm release install started, revision version 12.2. It's a newer version. Now in this demo, we also cover how the upgradation of the tag happens. Very standard process. So what we do is, okay, git checkout main, full origin. Sorry, I'm running out of time, but probably it won't take more than 2-3 minutes.
Yeah, no worries. I think you're good.
Okay. So here we just change the tag. Okay, so a developer can just change the tag here and can push the code. So we do a git. Right now I've pushed directly to main, but you can of course run it through a PR. And the change has been detected. Yeah. I think, yeah, that is much, I think, for the demo part. Sorry guys, it just break in between. I didn't know, but demos are expected to break.
All right.
I think I'll come back again to, sorry.
The demo was not with you, I said.
Yeah, exactly. All right. I'll come to the slides again, where on the later part, I want to discuss the challenges. Okay. Right. So demo, which failed in between. So I think the last observation and the challenges that I had with GitOps and my personal observation, I'm more than happy to take comments and feedback. So Git is not really designed for programmatic updates. So let's say that tomorrow, if you want to extend your CI pipeline, which should be writing those Docker tags via the pipeline itself, Like a developer says, no, I don't even want that. I want everything should be updated by itself. So option is to actually, you have to extend your CI pipeline, change those Docker tags. Well, for config map and everything, of course, you need DevOps folks, but those doesn't change that a lot. But Docker tags can be updated via you doing a set or a replace. That can work. Maintaining multiple repositories has a maintenance overhead, and across, if you have like different teams and everybody is actually pushing to the same repository, there is a chance that you want to create those Chinese walls in between. So that can become a problem. For Flux, multi-tenancy is still not there, which is supported by Argo, but Flux is working towards that. And the final part is SOPs makes PR reviews really inconvenient because everything is actually secure, encrypted. You can't really look and give a comment on GitHub. But again, it was a trade-off that we took, like, fine, okay, it's not really that a deal breaker for us. So yeah, I think that is pretty much it. These are the resources. I mean, of course, we wrote a blog on it recently. Then, of course, the documentation for GitOps and Flux Cd. And there is this very, really interesting book of GitOps and Kubernetes on Manning. And that should actually give a really, really good visibility about everything, from your traditional CD to your, what modern day GitOps will look like. Yeah, I'm Jaideep and I'm part of 112 Consulting. We are really looking to grow and hire. So yeah, more than happy to talk after the session. Thank you. Any questions?
Yeah, hi Jaideep, I had a question. Here.
Yeah, go on.
Great. I think the pain of having the networking overhead with Jenkins was very relatable, because having having a central Jenkins accessing multiple environments is something that is, it's a pipe dream which has started, but it never culminated. It was very interesting.
Yeah.
So wanted to know how much of, I was reading up on Flux and Argo CD and these things, how much of setup was through open source tooling, and is there any trade-off that Weaveworks offers when it comes to the paid?
So interestingly, what we really wanted, Flux actually ticked all the boxes. And not really sure that what's the difference between the enterprise offering. I haven't explored it yet because we didn't face that need of it. There was no limitation as such. But yeah, we'll have to actually look onto this. Other than that, Argo CD, Argo, of course, the only reason is, like, it became, to me, Argo looked really overwhelming at a point of time, because we didn't want to go into that direction of a canary or a very controlled kind of a deployment at that point of time, because it was dev and QA environments, and production we still wanted to control our old school way of using health charts. So hence didn't go towards that part.
And right now, if you want to see the historical deployment, what is the way to look at them? What was deployed like in this week or yesterday? For example, a tool like Jenkins or a Rundeck, even though they are push-based models, you will be able to view them, the job history and all. How do you do that in this case?
Sorry, can you repeat it? I actually lost your last 7 seconds.
I just wanted to get your perspective on how you look at the job history of the deployments in this case. If it was a push-based model like a Rundeck or a Jenkins, you will just go and look at Rundeck jobs or Jenkins jobs. So in this case, would you look at the Git commits and the merge requests and all of those things?
Yes. Everything is actually there. So so basically, you're talking about auditability, right? And that visibility. Yeah, I mean, okay, you can treat Slack as your poor man's log, but of course I wouldn't really recommend it. But at least because it's more of a very, like, you have, so whatever you change is actually part of your Git repository. But whatever actually failed, you generally have the tendency to act upon it just now. Your ops team is always sitting on call and see, like, something has broken, you need to go and fix it. So yeah, I mean, that is the only way right now I can suggest. But there is no auditability that what exactly failed. Yeah. Which you get in Rundeck for sure, that this failed or this passed.
Yeah, but then that's a push-based versus pull. It's a different paradigm altogether. But yeah.
Exactly. Yeah.
One question I had, Jagdeep, was if I had to do branch-based environments, like, for every new branch that I get as a developer, I want the entire development environment to be set up somewhere. Would that still work well with GitOps?
Yes, it can work with Toolkit. I mean, can you explain more in detail? Like, for example,
so even before merging, if I want
are you going
to,
towards the trunk?
Yeah, even before I merge, I want to have a preview environment, so to speak, right?
Yes, you can actually do that. Definitely, you can do that. I mean, you can do it by changing the images itself. I mean, it requires a bit of a manual work. That is what we had to do. Like before testing and rolling out our GitOps changes, we had to do those manual changes and test it on a separate branch before pushing it to the main branch, which was reconciled with the GitOps.
And the other question was, we of course did Flux a while back, and now they have also launched Flagger, which is they tout as progressive delivery. So where is this going? From GitOps progressive delivery, like what is the comparison? I have no idea. What progressive delivery really means.
Well, I mean, I think I actually just looking and dabbling with Argo recently. I'm still dabbling with it, so I can probably in a better position to answer when we meet next. But yeah, like I think Argo is trying to catch it up with Flux is trying to catch it up with Argo, and because Argo in itself has actually gone quite ahead, to be honest, because of all the fanciness and the UI that it provides and the control that you can have at every resource level, which is something really great. Doing it with Flux can be a bit tricky, to be honest.
Right. And how does Flux versus Flagger compare?
Yeah, so Flux versus Flagger, I was still looking at it. I think this question actually came again and again that how do you do this whole canary based kind of a deployment or an EV deployments kind of a thing. So yeah, pretty, I would say new. I'm not sure that if it has as matured at what Argo actually provides, to be honest, or Jenkins X.
Right. Yeah, thanks.
Anyone else? Yeah. Cool.
Anybody has any questions, please go ahead. Thanks, for coming in again, Jaideep, Abhimanyu, and Pallab. And I'll stop the live stream, but